Sure. All right, everyone. Thank you for coming to our live Q&A session. Yep, it looks like it's working, hopefully. Yeah, can you guys hear us? It's a good question on how well my computer mic works. You can hear it? Yep. Awesome. All right, so we're just going to start by asking a couple of questions that I wrote up until we get some in the chat. So this one's for anyone. What's one piece of advice you give teams for this year?
Cones are going to tip over and pieces are going to be strewn everywhere. So be able to grab them from the ground, be able to grab, louder? All right. Cones are going to be tipped over, pieces are going to be strewn on the floor. So you're going to be able to have to pick up from the floor as well as the power station or the charging station that they give it to you. Substation? That's what they call it? Cool.
To add on to that, think about picking up cones from a tipped over position rather than from an upright position.
Also, any orientation, no matter where it's pointing.
Mm-hmm.
Don't use suction. I'll give a piece of more general advice. You're going to have setbacks and things aren't going to work. You look at us, that problems video, we were all very defeated by that point. You just got to keep going and keep working at it, make changes and just keep testing and eventually you'll get there. So.
And prototype more than we did.
Okay. What's one part of the robot that you guys would change if you could do it again?
So I think our one big thing, our clamp didn't work as well as we would hope. I think we have a decent idea and we could probably get it working with some more time. But there's definitely some minor changes to there. Our big change would definitely be our arm. The pivoting arm seemed like a good idea at the beginning. Once we start testing with it and driving around, there's a lot, it jumps up and down a lot. It's really tough to control and this gear reduction is quite heavy. We stripped out one of these versaplanetary gearboxes. We completely sheared one of the sun gears on it. And so that's something that we would definitely strongly urge to move away from. So
I'd add more wheels on the gripping mechanism so it holds the cone more securely rather than just using two.
What are some things that you think teams might have overlooked or think teams might overlook?
The cones falling down is one. Also being able to rescore pieces on the floor. Or being able to move them for a link if you don't have time for another cycle. It's supposed to be beneficial.
one thing we had discussed too was possibly moving cones from the first tier up to the third tier if we have the capability. So our team could come over with one member of our alliance if they scored on the bottom and say we have not full time to go back and do a full cycle to get a cone up to the third row. You could pick one up from the base and move it up. So
getting onto the rocker, whatever that was called, the charging station, those ramps are deceivingly steep. They don't look like it in the reveal video, but they are surprisingly steep when you're trying to drive up them.
All right, anything else for that one? All right, so here's a question from someone watching. What would you do to increase the weight distribution of the robot? It seems like the weight distribution limits the speed of the robot.
We would put steel plate in the bottom because we're quite low on weight. We're probably in the 80 to 90 pound range, so we can have quite a bit of plate in the bottom. We just didn't have that access to material at the time.
one thing to note on that, if you are adding weight, coming from an RI, they do have to be securely mounted, and zip ties and duct tape is not securely mounted. So
Zip ties and duct tape are indestructible.
General tip for, I would assume you're talking about kind of the tippiness of this robot, especially when the arm is all the way out. From a code standpoint, you can add rate limiters to being able to speed up and slow down the robot, just so that it won't be as jerky, and that'll help a little bit. The only downside is that then you're going to start to feel a little sloppy in your driving. it'll feel sloppy when you're driving it because it won't react as quickly.
Another good thing to consider is for the drivers, have a slow mode button that they can either hold or toggle in when they get into either the charging station or the community, so they can, or substation or the community, so they can slow down and be precise and then speed back up when they have to go across the field.
All right. What would you say is your favorite aspect of the robot?
You can complete pretty much all tasks necessary, and it was finished in 72 hours with time for the programmers to be able to program.
Yeah, it's a really simple design and it works pretty well. There's definitely improvements that could be made. For one, we were hoping to have a kind of funneling system at the front to push game objects into inside of our bumpers, into the claw, and that didn't work out for us. In the end,
Made up for it.
All right, any other comments on that one? All right, so obviously we have some pneumatics on the robot. What kind of recommendations would you give to teams that have less experience with pneumatics?
So there's, if you go on Chief Delphi, there's a ton of posts with great descriptions of how to plumb pneumatics. Also in the game manual itself, it describes, I mean, there's a whole circuit there that describes where you need what can be where, and what components you can use. They are kind of daunting at first. Read through Chief Delphi. I mean, find teams in your area. There's plenty of information online and elsewhere to find it. Otherwise, if you do have specific questions, shoot us a message. We'll get back to you. We want to help you guys, so we'll get any information out to you that you need. So
Always remember to leave extra tubing if you have moving parts like we do, so that you have room for tubing, because it can be very easily ripped out or quickly too short. Once you start doing it, it's pretty simple. It's not as challenging as it seems, but yeah, using those resources are quite useful.
just from a programming aspect, they're also very simple to program. It's about 2 to 3 lines of code to get a simple pneumatic system like this claw working.
All right. So what made you guys go with the single arm versus using a ladder or a lift?
So it was kind of the first thing we came up with. We kind of had discussed as a group some different, either using an elevator or using some different methods. Kind of from brief napkin CAD, this is what we decided would fit. And I mean, probably within the first hour of our time is when we decided on our full design. So looking back, we definitely change it and go to something else for sure, as opposed to just this rotating arm. That's pretty jank. I'm not gonna lie. So really, it really was just the first thing we came up with, and by the time we got to the point where it's not great, it was too late to go back. So
one advantage of it though is that a lot of the extension that you need is in the arm itself. So you don't need to be lifting a very large multi-stage extension all the way up.
It also looks like a lot of robot designs that you would see in the commercial market, a singular arm with a grabber on the end, look pretty typical, so we kind of just went with that design. So
yeah, it was meant to be simple, so it was lift up to hit the first stage or the second row, one extension out full to hit the third. So that's really all we were shooting for.
All right. Do one of you want to just explain a little bit of what our design process was?
Yeah, so we started off like all teams really should. We started off everyone together, including your programmers and everyone on the team. We have a brainstorming session, kind of just come up with ideas, get a brief idea of what this robot's going to look like. Not deciding on one, like as soon as you hear one good idea, we're not stopping there. We're going to just keep brainstorming, coming up with ideas. For us, we did not spend very much time brainstorming. you guys should spend, a couple hours really just hammering out ideas. From there, we kind of broke off into groups and design. We broke it into individual components from what we thought the whole robot should look like. So we had Bardos design the whole claw mechanism. Me and Calvin had broken off and started kind of looking at how this arm was going to look with that extension on there. And then our controls and everyone else started working on getting all of our other stuff working and kind of taking note of what we have. That was one of our biggest challenges is we're designing around what we have in stock. We don't have time to go get parts. So after we kind of broke off into those groups and design, had a more concrete design, we started fabricating right away. We had loose prototypes of some things, but for our part, we just went for it. You guys should really prototype. Don't build things out of aluminum first. Like 80-20 T-slots, great to prototype, figure out where holes need to go. But even things like 2x4s, fantastic. They'll hold for a prototype. Figure out where things need to be, what works. You can get a design in your head and on paper that looks great, and go to test it. And it's not gonna work so well once you start spinning with motors and trying to control it. So yeah, from there we went into manufacturing. Once we manufactured prototypes, we're testing them individually, going back, making a ton of changes, redesigning a lot of things, redesigning our whole claw, figuring out where we're going to mount like motors, sensors, and everything else we need. So yeah, after testing, then it's step back from the robot and let our programmers really just work their magic and figure out how to control the thing and fine tune it. So.
All right. So on our intake, I believe you're talking about the compliant wheels that rotate. Do you think you could use something smaller or thinner?
So you could use something smaller, but it's harder than you have to pull your claw in more to grip every part of the cone. Whereas if you use something like a compliant wheel or even using more compliant wheels, it's much easier to get a grip onto the cone because the cone is a weird shape. It's not like a normal mechanism that you would use to kind of pick it up. Whereas with like the cube, it's pretty simple and easy. So you could use something smaller, or even you could use like solid blocks that just press into the cone. But it just makes it more difficult if you're going to use something smaller.
And then another way to also use something smaller, you would have to get pistons with longer stroke length. So we only had 3-inch stroke, which added up to 6-inch stroke. It would be better to use 2 4s or something with a 6 to an 8-inch stroke length. So something that has more movement and allows you to use something that works for both your cube and your cone. So something that can actually move a little bit more would allow you to have a smaller gripper at the end.
What are some cases that you guys would use motors versus pneumatics?
Rotation.
Yeah, so if anything has to rotate, you're going to use a motor. If it's just going to be a basic in and out or something like that, it's going to be...
Also only 2 positions.
Yep, it's going to be pneumatics. Pneumatics are also in or out. So if you need to have somewhere in between that, you can't use pneumatics for that.
Mm-hmm.
But if it just needs to be either all the way out or all the way in, pneumatics are perfect for something like that.
Also, if it needs to do it fast, that's choice.
Right, adding on to that question, do you think with the way our intake is right now, do you think you could have redesigned it to use motors instead of pneumatics?
Yes.
You could, but it would add a lot more complexity to the system, and it would make it much heavier because pistons are not very heavy. They're pretty lightweight, so it's pretty easy to maneuver and manipulate. But once you start adding motors, then you got gearboxes and gears trying to figure out the right ratio and how fast you're trying to intake it. So it would make the system a lot more complicated and harder to wire. There's a lot more wires going to that system now. So you could build it with motors, but unless you're unless you can figure out a very simple design, I wouldn't recommend intaking with motors.
Another thing is that the pneumatics are going to have 0 power draw to hold tension. closed. It's going to be all air pressure that you've already gotten, and it's all going to be stored. Where with motors, you're going to be probably constantly needing to drive those closed to hold the pressure on that. So it's going to up your power draw and potentially lead to brownouts at the end of the match, depending on how much you're doing it.
Pneumatics are a great way to get a lot of force very quickly. And the other reason why they're great is, so in our case, we don't close our grab or our pincher all the way. It just pinches down as far as it can on the cone with the amount of force it has. So we're running 15 psi working pressure to those
I
cylinders.
think we left it to 20.
20 psi.
35.
I thought it was 35.
35 psi working pressure to those cylinders. And so it doesn't close all the way. It gets as far as it can on the cone, and it'll stop wherever it needs to. And like Brandon said, you don't need to hold that there. It doesn't change on how you control it. So they're a lot more compliant and self-regulating and kind of how much they grab. So
That's pretty much it.
All right. How do teams build robots to be stable on the charge station when other robots are getting onto the charge station?
Be bottom heavy and just have good drivers. If you're a tank drive, I would say that angling yourself sideways would help, or if you're a swerve drive, have a button to just be able to turn the motors to an X position if you find a way to do that. I haven't programmed them, so I'm not sure if there's a
Also,
way to do it.
position, I think, is really important. Make sure to stay out of the way of other robots that need to get on.
A lot of that is going to come from you talking with other alliance members and working with the other teams that you are playing with. That to try and position yourselves in a way that you're not sitting there throwing each other off or running into each other. And yeah, turning sideways with a tank drive would cause you to not sit there and slip and slide. But yeah, a lot of it just comes from communication with your teams.
What are some rules that you think teams are going to have to look out for this year? I'll give you a minute to look at that.
You can only extend in one direction unless you're in the community. And if your bumpers are in the enemy's subsystem or community at all, no matter who initiates contact, that's a foul.
you're also not allowed to extend, have any parts of your robot outside your frame perimeter inside the other alliance's community loading zone. Even any part of your bumpers can't enter that area while you're extended outside your frame perimeter. So make sure you have some way to take your intake back in if you do end up going in there. Your loading zone's right next to their community. It's very easy to cross that border. So.
You guys see anything else? Well, if you find something, we can always come back to it too. All right, I know 2 of you have been robot inspectors at competitions. What's some advice you'd give as a robot inspector?
Read the rules on pneumatics, right? There's a lot of rules on where stuff can be and how it's plumbed together. So stuff like your main pressure relief valve that has to relieve at 125 PSI. To test that, if you have just a normal digital pressure switch, like the one we got on our robot over here, just has the 2 prongs sticking off. After your compressor shuts off at 120 PSI, you can bridge those contacts with a screwdriver or something. Watch your pressure gauge. As soon as it gets to 125, your pressure relief valve should be going off. You can adjust those. There's basically, you would loosen the jam nut and you can loosen those until they start relieving air. The other thing with that is it has to be connected to your compressor through hard fittings only. It can't go through any tubing. The reason that is a thing is because tubing is pretty easy to pinch or melt or fuse. And if that happens, everything before that is still going to build pressure in your loop. And that compressor, although it takes a while to get to a point where it's dangerous, now you could build that small area up to a couple hundred PSI and blow something and start making shrapnel. So having that right next to the compressor is just a huge safety thing. So. The other thing would be your electrical components, your PDH or PDP have to be visible for inspection. That is a rule. And we will have to see it. If it's covered under a plate because you wanted to protect it, you'll have to remove that, and it's just kind of a hassle during inspection. So make sure that's somewhere we can see all your breakers. We have to see all the wire gauge going into those. In the rules, it specifies what wire gauge you can have for what breaker you have installed. 40 ampere limited, 12 gauge wire, nothing smaller. If you have 14 gauge in there, you have to have a 30 amp breaker. So follow that whole table and what you have plugged into your PDH. So those are usually the two big things. Really, until you start inspecting it at the competition for the game, we won't see any like specific things for it. I don't think there's anything huge for this game specifically that we have to worry about. We have plenty of room that you can extend outside your frame perimeter that I don't think much teams are going to exceed that very easily. So.
Well, for the arm, you gotta make sure if you're not coming out the back and you go forward.
Right. Yeah, making sure that you do only go outside one side of your robot at a time. Yeah, the judges on the field are watching that and will call you and we will come inspect it after. So.
Brandon, anything you want to add?
I guess just don't modify any of your pneumatics components is a big thing. We had thrown a sticker on our pneumatics tank. Stuff like that you can't do. So we took that off. That's even considered modifying them. So pretty much anything outside of just cutting pneumatics tubing, putting fittings on is going to be not allowed.
All right. What do you think you'll see the most creativity on robots this season?
Claws, probably. Claws are arm styles, so I don't know what the claw is and what connects to it. I'm foreseeing a lot of different ideas and styles for that.
Yeah, just how teams pick up cones. I could see that being either everyone's the same or there's some really cool different ways of picking them up.
Even when we were brainstorming, I know we had at least two pretty distinct methods that we were talking about how to grab the cone and manipulate it.
What are you most excited to see on all the robots?
I'm just excited to see them. That's one of my favorite things of being in RI is going around to different teams and just hearing their thought process, what made them decide, and just seeing the robots. All of us love this stuff. This is our hobby. Like we do this for fun. So going to those competitions and just seeing all the robots is really fun. So.
If you had 2 more hours, what would you add?
Probably some more sleep.
Or more weight, one of the two.
Yeah. Yeah, getting that more bottom heavy just because we have so much extra weight that we could have added, that we could have improved our driving fairly significantly, probably, just by adding some weight to the bottom.
All right, here's a fun one from the chat. So, how do you think an elite team like the Cheesy Poofs would approach this game? And how do you imagine that really good robot?
6-axis robot arm mounted on a swerve chassis.
Really fast cycle time.
They are going to be able to drive over a game piece and own it, and they're not going to drop it. It's going to be very touch it, own it. You drive over a game piece, no matter what orientation it's at, it's going to be somehow funneled into your robot, gotten to a consistent orientation, and be able to pick it up very
Imagine
quickly.
this year they probably won't even have to stop to place, or if it is barely half a second, just drive up, drop, back away.
We're going to see some automation on placement using the April tags as well.
I theorize with April tags and proper field design due to the little amount of defense I think we're going to see this year. there's going to be quite a bit of automation and cycle times that once you enter your safe zones, it's pretty much going to be press a button and place or pick up.
All right, I'm gonna try to phrase this well for Brandon. How would you approach doing your vision tracking this year, whether it's with the reflective tape or the April tags?
Yeah, where is the vision tape at? I'm not entirely sure where that was. I know
It's
that,
on the top of the
Here,
rock.
here you go. So your reflective tapes on the top of your rods, your April tags are here.
right, okay. So you could either do just April tags since they're always gonna be in the middle of a group. So you could either do something where your robot just lines up with the middle using April tags and then has an arm that goes up and to the side or whatever to be able to hit anywhere in that like section. Or you could use vision tape for placing the cones. You could see where the vision tape is, somehow automate that. Or you could do some sort of a combination of both where you use an April tag combined with vision in order to find a cone, where to place a cone.
If you had to choose one of them, which one do you think you would use?
I think that the best way would be to use April tags, and then either you're going to move your April tag camera to the side in order to line up your camera with the cones, or to line up your camera so that you can be in line with the cones, or allow your arm to move to the side so that your robot stays where you are, but the cone moves to the side, so you can always see that April tag.
Do you think that April tag placement was on purpose? Because it seems a little bit difficult to have to move side to side based on where it is.
I wouldn't be surprised if it was to kind of force some of that sideways motion in your tracking, because that's most likely too close. You could probably even have 3 separate cameras facing, one facing directly forward and 2 facing kind of off the side to look at them if you wanted to go that route.
How did you manage time in this short period?
Go as fast and as hard as we could, just every part, when we know it needs to be made, confirm what people want, make it and put it on and test it and keep doing that until the robot's built.
Dividing up the jobs, trying to find people that are good at certain things but may not be so very good at other things, and being able to work together and communicate and just dividing up. Plus we had 15 some odd people working on this, so it makes it pretty easy to get an assortment of things done all at the same time.
Yep, we were always working on a couple things at once. There was never a moment where we were sitting in the shop and not doing something. At the end, we took like a 6-hour break. And that was only because we had time and we didn't have the parts to fix our problems.
So how do you think these things can be applied to a full season?
Man, I guess
Just always have something you're working on. Don't show up to the shop and just mess around and not do anything. If you want to get stuff done, you got to have people working on it, multiple projects going at once. Don't spend too much time on something, and make a decision on what you're going to do early enough in the season where you can really improve your design and get it working really well.
And based on the decision, like we said, figure out what people's strengths are, figure out their weaknesses, figure out freshmen and seniors or groups in between that have experience on some things and can lead others and work in teams to teach people and figure out kind of what everyone's strongest points are as well as their weakest points, and figure out how to shore your team up in all of their shortcomings and ensure you're solid in other places. So if someone's really good at manufacturing and someone's a freshman, bring that freshman in with that person who's really good at manufacturing, have them see what the, probably older member is doing and see how they work and how they, figure out how parts are made and come up with a design for manufacturing as well as placement and repair.
Don't get too attached to any component. Be willing to change anything, even if you work like 3 weeks on it. If there's a clearly better, easier way to do it, just drop what you've been working on and do that, or at least prototype it.
So first is all about learning, and you guys were just kind of saying that, try to find your strengths and weaknesses. How can you expand on those weaknesses? Say, I've never programmed before, but I and I'm really good at machining. How can I try to grow in both during the regular season?
My best tip would be to, if you have programmers that are willing to teach you and you're willing to work with, kind of just be next to them, watch what they're doing, ask questions. Don't be afraid to ask any questions or get involved in something, even if you have no experience in it. I don't think any of us had experience when we first started. You kind of just see something you like and you kind of just go with the people that are doing it. And if you want to learn something else, you always can. It doesn't hurt to know as much as you can, or even working on every different part of the robot, from wiring it to building it to designing it.
And I noticed you did say during regular season, but another really good way to do it is maybe a week or so before reveal, ask people and figure out, okay, well, what do we want to do? What do we know? What are our strengths? What are our weaknesses? Can we do just take a little pre-week or even a pre-season, like I've seen a lot of really good teams do. It'll do a few weeks before the regular season of teaching their newcomers and the people who are new to the team, and using more experienced members to teach those kids and make sure that they have the skills built before the regular season even begins. But now that we're in the regular season, exactly what he said, figure out the people you gravitate towards and like what they're doing and learn those skills.
The other thing, as a senior member, answer questions. It doesn't hurt. It's usually pretty easy. Or if someone wants to learn how to do something, like I'm a mechanical person, so I require gearboxes all the time. If someone wants to learn, show them. It takes no time out of your day you're already doing it, so it's not hard to show them or even let them do it and work around with it. And you have well over a month to work on this thing, so it's not going to hurt if you take an extra 20 minutes to work with someone and kind of teach them something new.
Especially on the code and electrical side, again, there's tons of resources online. First has been around a long time. This control system has been used for the past 10 years, I think, with the Rio and the PDH, or 5 or 6 or whatever it's been. Teams have put out information. There's a ton of posts on Chief Delphi explaining how stuff works, how it can be improved. Just don't be afraid to go online and do research, and just jump right in. You're not going to be an expert right away. You'll learn as it goes, and that's just kind of how things work. So.
All right, so there's someone in the chat asking about part of the design. So the cutout in the frame, what's the purpose of it? Is it for getting closer to the grid? Is it for intaking?
It was there.
Well, yes.
It also helps keep all your components inside of your frame before you start, because you must be within your frame perimeter when you start the match. So it helps keep everything inside, since the arm is meant to go all the way to the ground. It's usually decently difficult to keep it inside your frame if you're trying to get it to go to the ground as well.
Part of the initial plan was to just always be picking up the cone or the cube in the same spot. It doesn't, with how the design ended up, it doesn't quite end up working like that. But initially we were planning on just being able to drive forward on top of a cone, pinch down, and that's it. We don't have to adjust our arm. It all the cone would file itself in right where it needs to be. This avoids any time kind of maneuvering your arm where you want it outside your robot, or however you pick up your game components. It's just you drive forward and it puts it in the spot you need it, and you just go. It's really where it kind of started. So
the arm ended up just being a little bit too long and not giving us enough room to fit that in there. So if we could redesign just the arm like this, I think we would have made it a little bit shorter and made our extender a little bit longer to give a little bit more room for that funneling mechanism to fit in there.
We got an intake design, some wheels that would spin to kind of help us get control of objects we kind of run into sideways, and a funnel that would make sure the cone's always in known orientation, so you can always grab right spot. But just in the end, we didn't have room for that.
Yeah, and our known orientation was going to be either upright or tipped directly away from us or directly towards us.
So what's some advice that you guys have for rookie teams this season? This is everything from what kind of tools they should have to how they might what might be a good way to approach building their robot and designing it?
So I guess my thing would be start off small. Don't go looking at teams and trying to, you know, work on the same complex robot that they're working on. Focus on small milestones like getting the drive base moving or drivetrain moving. Then work on adding stuff to that, working on picking up cones, implementing stuff. You can score with just a drivetrain if you just push a cone across the field. So focus on that. Reach out to teams in your area as well. They're a fantastic resource. That's one of the things that's fantastic about FIRST is you may competition, but teams are always willing to help and teach you. We had teams in our area that would, with my home team, that we would go visit and just talk with them on what they were planning, and we would just powwow together. So.
And another thing that I noticed in my home team back home, I noticed their team's skill and expertise level jumped immensely with CAD. So I would be getting with CADing and actually properly planning out your robot, figuring out where things go. This will allow you to save materials and allow you to truly plan out so you use as few materials as possible to make a fully functioning robot. So this will allow you to understand and have a good concept of what the robot should look like and how it should be made, where holes should go, where pieces should be sized before you even begin to make it. So this will allow you to actually come up with a true concept before you kind of start throwing it together and end up with your head under the water and being really confused that, okay, this is now kind of a hunk of metal in our room. What do we really want to actually turn this into? So I would get good with CAD and, learn how to use CAD to your true, potential and learn how to use it to make your team better.
Yeah, don't shoot to be the best spot at a competition as a rookie. It's most likely not going to happen. You can shoot for something just about this good. This would be, I would say, the top of your realistic skill zone. I know my team, they're pretty good now. Our rookie year, we were very bad. So it's going to be a learning year, but it'll get better as people start to gain experience.
And don't be afraid to take ideas from other teams. If you see anything that you think you can do, that you're able to do with your materials, and you think might work, don't be afraid to just steal the idea and do it yourself, or take inspiration and change it to a point where you can do it.
All right, I'm just going to ask this as a reference point. What are your team numbers, just so they all get an idea of how long has your team been a team? What kind of experience do you guys have?
That's
Your
like
teams
rookie
have.
years in there too.
If you know the
I'm
rookie
from
years.
Team 2509. I have no clue when our team started. We were probably 15 years old at this point. I have 4 years in high school with FIRST and then volunteering through FIRST.
From Team 4632, the Monty Pythons. I also don't know when our team started. I think it's 2015 or 2016, somewhere in there. So.
Team 7028, we started in 2018, Binary Battalion.
Also from Team 7028.
7048 and 1 year on 4818.
So what do you think would be the best drivetrain for this season? And if it's not Swerve, tell me what your thoughts are on Swerve.
I think it would be tank drive. It would be the easiest to get up the ramps with, since you're constantly having to drive over a ramp, or even when you're trying to ramp. I never worked with a Swerve drive. I think you could do it just fine and be fast with it, but I think it's going to be a lot harder to get up the ramp with a Swerve drive.
I think the ramp, yes, will be a complication with Swerve drive, but if you are looking at pathing here, there is a way to avoid that. So Swerve would be a valid option, and it would also allow you to rotate yourself into the direction you're going to need to pick pieces. So both would be really solid options. I wouldn't really recommend anything other than those two for this season. So if you're a team that's new to it or wants to build something pretty simple, a tank is definitely a viable option. But if you're a team that wants to try something complicated and wants to see how good they can get, go for a Swerve. Either way, completely valid drivetrains.
So this robot right here is going to be it's a no drop center tank drive with 2 grippy wheels in the back and a set of omnis in the front. And what that allows you to do is basically you're going to have a really stable robot. It's going to be a tank drive, which works really well. And it's still going to allow you to turn really well without scrubbing. As far as swerve goes, I think the biggest problem will be getting onto the charge stations. I don't know. I know swerve drive is really dependent on encoder values, and to get onto the charging station, your wheels are going to end up in the air a lot, I would assume. And I don't know how much that would screw with your like odometry and just your driving in general.
All right. Do you want to give your thoughts and opinions on mechanisms for this game too? I know I have a thought.
Don't use them. You are going to slide off the charging station. If you want to go with a drivetrain that can move side to side, swerve is going to be your best bet.
All right. How do you go about determining and planning gear ratios and motors and pressures, that kind of thing? All little details.
Pressures, it's fairly standard. The compressor maxed out at like 120 psi, and then your working pressure is usually maxed at like 60. But I wouldn't, with this game, I wouldn't put it to 60 because I think the cube is going to pop quite easily. So with pressure, I'd probably stick around 20 to 30 psi in there. You don't really need to have any more than that, and unless you're using the pressure to actuate like an extender that we have. If you were to use a piston instead of wheels, then you could bump up the psi. But yeah, I'd stick around probably about 20, 30 psi.
Yeah, start small and increase it if you need more.
One thing to note on the pressures too, figuring out the force that a pneumatic piston exerts at a certain pressure, super easy. So if you have a 1/2 inch bore, take the area of a 1/2 inch diameter or 1/2 inch, 1/2 inch diameter circle, multiply that by your pressure, and then that's your force in whatever unit. So if you took that as 1/2 inch, that's going to end up give you in pounds. That's how much force that cylinder is going to exert. You get a little less coming back for reasons I won't get into. So your retraction force is usually a little less. But pushing out, it's going to be that formula. It's super easy to figure out. And from there, you can kind of figure out how much force you want. Take your fingers. I mean, if it takes pretty much all your might to get what you want, give it a couple 100 pounds and go from there. But yeah, I highly encourage teams to do math. It's a big part of engineering. And especially simple math like that, it feels great to calculate and get small wins with that. So.
That also goes into your gear ratios. You know the torque that your motor outputs. You know what you have to multiply that by in order to get something to move. And you can do the simple math based on your weights, your lengths, your foot-pounds that it's going to take. Figure out your torque from your motor. Figure out what your gear ratio will get you. And figure out kind of what that'll end up with. Figure out what each of your parts can take in strength before you start messing around with it.
Always overestimate how heavy
Yes.
things will be.
You're also, if you don't know how to do the math or you don't know the equations for the math, there are plenty of first teams that probably do know the equations, or even college teams that you could reach out to, even us, or even just looking up the equations on Google. They're usually pretty simple to find. They're not hard. Or even with a gear ratio, there's calculators that'll do it for you. If you just input your numbers into it, and it will spit out the correct number.
Anything else on that one? All right. Do you think it's important to control the pitch of the cone before scoring it? For example, give it a slight tilt so you can slam into the pole with it instead of just positioning it carefully above the pole.
When we were scoring, I don't think it was that important. I mean, if you want to do it quick and consistent, maybe a bit more, but with just maybe half a second, we were able to mostly maneuver it onto the pole, no matter what the angle was.
Yeah, so if you haven't noticed, our wheels on our grabber spin to allow the cone to always angle downwards. And it doesn't work
look it up a little further.
It doesn't work fantastically, but a team could definitely get those working better. And with a more consistent grab angle, like if we grab the cones at the top, it works phenomenally. If we grab the cones closer to the base, it doesn't work as well. And we kind of have to slam into the poles to get them to go on correctly. But it works well enough for us, at least. In driving it, it's pretty easy to just get a cone on there pretty quickly at just about any angle, especially when it's straight up and down. So, I mean, it could be useful, depending on the robot design, to kind of angle it a little bit out like this, so it just kind of pops onto it. But
I do think some of that will come with driver practice too, because once your drivers are more experienced and familiar with how your robot works, you'll get a pretty good idea of if it is necessary. I know that's kind of after the fact when you finally have your design together, but I think once we had some decent practice in, we were doing pretty well regardless of the angle.
We had about an hour-ish of driver practice, maybe 2 hours of driver practice, and we were kind of getting the hang of it. So with hours of driver practice, I think you could make something like this even manageable and a pretty decent bot.
What are some pros and cons you think of with chains versus belts?
Chains are less likely to slip than a belt, but a belt is a lot lighter. So usually in like your drivetrain, it's a lot easier to use a belted system because you're usually not running into as much slippage issues, and there's not really a whole lot of weight necessarily that you're lifting with the belts. But with like the chain up here, you have a lot of weight that's coming onto the chain that the chain needs to withstand, and you don't want that slipping at all through under the weight. Where if you were to use a belt, you run into the issues of it being too heavy and causing the belt to pop off the sprockets.
Yeah, one thing to note as well, chains are a lot more forgiving if you don't have as much wrap angle on your pulley. Belts, if you don't, I mean, typically you want over 180 degrees of wrap angle on a pulley on a belt. They don't work so well if you have, only like a couple of the cogs engaged. So if you go to like a 4-inch pulley up here and a 1-inch down here, you're not going to get very much engagement down here, and you're not going to transfer the torque very efficiently. So chains are a lot more forgiving of that, just the way they engage. So it's another thing to note.
Chains also allow you to splice and resize much easier than, the belts that we have. Those, you pretty much have to get them in specific sizes unless you want to go through a whole.
If you're going to use belts, measure.
Yes.
Because if they are not right, they will be too loose and will not work.
And for both, spring-loaded automatic chain tensioners and belt tensioners, fantastic. And it's pretty much a must. It's an easy thing to forget about, but they'll take up any slack, especially on belts. They stretch quite a bit over time and very quickly. And chains will too. You may not think of it looking at a number 35 chain and seeing how big it is, but they will stretch and they will just fall off during a match. So automatic chain tensioners are a fantastic thing.
And this goes back to CAD, I guess. When you do use belts or chains, you can figure out there's calculators online as well as formulas you can use to figure out exact sizing for sprocket size or gear tooth size, as well as belt length and your chain length. You can do that in CAD, and you can get your parts pretty much exact. So you won't need to worry about, although you do need a tensioner still, you won't need to worry about having a lot of slop or absolutely zero slop and unable to get your chain or belt on. So yet again, CAD and math.
So how likely do you think it'll be that when teams are aligning their robots to place cones, that they'll hit the pole and the cone will fall? And how do you think that can be prevented?
I think teams that are automated, have good automation systems, is going to be pretty unlikely that happens to them unless they're getting bumped, which they probably shouldn't be, as long as their alliance members are playing nice.
Or the other team is not just there to rack up points.
Yep. teams that are manually driving like us, I can definitely see it being a little bit of an issue. Although it's still not too terrible to line up, even with fairly not ideal visibility.
And then coming with that driver practice and understanding when you do come in much higher than you think you're gonna need. So say your post is like here, don't come in here, come in here, because you have a 6'6" or something to that degree amount of height you have. So play towards the top end of that so you can get in well over the top and set down on instead of kind of sliding it in from the front. So that'll come with driver practice, but understand that you're gonna wanna come in a little bit over and drop it down on.
Yeah, when we tested our height to see how high we could extend our arm up, it's quite high over that bar.
So have you guys thought at all about just dropping game pieces into your robot from the single substation, like it was with like the small balls that they dropped into a robot in 2017?
So if you do that, that limits your pickup a lot. That's totally viable, but that is going to limit you to having to run across the field. If you're a fast cycler that has to do that, you are going to get defense played on you. People are going to block you from getting there. You don't want that to happen. You want to be able to pick up from anywhere and even unscore your own game pieces to move them to a higher scoring place in the worst case scenario. Just moving them from the floor in your community all the way up to the top, or from the second level to the top.
So on the note of defense, how prominent do you think defense is going to be in this year's game?
In I'm gonna just affectionately call it no man's land. So the area between your charging station and your substation area, that has no safe zone. So between that, there's going to be the rogue players that are going to come across and just hit you while you're in there, just try to slow down your cycle time. But due to the amount of safe zones we have this year, I'm thinking once you're in those, it's going to be very low because of the penalties. And I'm thinking once traversing between the two is going to be a slight problem. But other than that, I don't think it'll be too bad.
I think we're going to see full speed collisions in the middle. As teams are running by, you're going to be accidentally playing defense on each other. You're going to be running into people. It's going to be bumper cars in the middle. And then there's going to be teams actively seeking to block routes.
There's going to be lots of collisions. I don't think there's going to be a lot of pinning. I think mostly just messing up your cycle time, trying to make you drop a game piece. And if you are a person who can't pick up from the floor, dropping that game piece is going to just be devastating to your cycle times.
Yeah, I think the collisions are going to be very similar to that of 2017 with trying to collect the cogs. Because if you, like with the cogs, if you dropped one and you couldn't pick it up from the floor, you had to go get a new one. There's nothing you could do with it. And yeah, you ran into other teams and your own teams quite a lot.
I feel like counter defense could be a thing too. Maybe you have a really fast cycler. The opponents don't really have as fast of a cycler. It might be more valuable for your defense bot to play defense on the other defense bot and just keep them out of the way.
Especially with how open the center of the field is, like Brandon said, you're going to get hit hard when you do get hit there. Teams are going to have a lot of time to get up to speed, and it's going to be quite easy to get hit as you're going across the field to the loading zone. So
build very robust.
All right, here's a fun one. If a team wants to get more game pieces, but they're out of stock, what could be a good replacement?
Those little gym traffic cones, they have in PE, those are pretty similar.
Yeah, typically they're not game pieces that first made. You could probably find something that's just not off anywhere. You can find something on Amazon that's pretty similar dimensions.
I'm sure you could find an inflatable square.
Yeah, those cubes would probably be the hardest thing to find.
If you can't find a cube, if you get a ball just for grabbing, it'll be mostly the same.
And actually, if you learn off a ball, it'll probably be easier to then pick up the cube.
Yeah, if you haven't seen the cubes yet, they're actually quite round. They're not very cube.
Yeah.
What are your thoughts on the central shared hub that's for cooperation?
I think most of the time you're going to want to go for the cooperation bonus, just for that extra rank point taking down a link. And even if you can only score high, if you can score high, you want to score high and fill up all those as much as you can. And if you can only score mid, you want to score as high as possible. So you scoring the competition is usually just gonna be a byproduct of getting as high a score as possible, regardless.
Your more ranking points is always gonna hurt, or always gonna help you, so. Always gonna help you, so I mean, the easier it is to get that extra rank point.
Yeah, if you're confident, the only scenarios where you would probably not fill that first are if you don't need the lowering of the cap in order to get that ranking point. You don't really want to help your opponents get it in the rankings. Or if there is another team that you're trying to overtake in the rankings on the other alliance, you don't want to help them get a ranking point either. Unless they're going to get that ranking point anyways, in which case you're still going to want to do that because you want to get that ranking point to keep up.
Even if you can make the point without it, it's more points to make it with it. Because there's only 2 other stations scoring all high. If you score more than 6 game pieces, you're gonna at least score 1 on either the high or mid if you can only score mid. So most teams it's gonna be worth it to do that. If not first, then pretty soon.
Also figuring out what your other alliance members can do, because if you're a high bot and they're both low bots, then you just help them fill up the low, and then, or they fill up the low and you sit there and just cycle them up so that they can keep cycling.
So, do you guys remember what our cycle time was with just cones, just cubes, and then with both?
It wasn't. We didn't do
We
just
never
cones.
got an accurate cross field cycle, just floor to.
Yeah, we ran a practice match without an auto, and we could do 5 of any game piece about in the 2 minutes 15 seconds, and that's not accounting for any defense or
Those were
driving
all
across
in-
the field.
In our communities.
Yeah,
Game pieces. Communities.
we were driving slow. We would be definitely driving faster to get across the field. So it kind of simulated the time that it would maybe take to cross the field. But the way we were doing it, we were just picking up our game pieces, tossing them back out, and going to pick them up again. So as accurate as we could get it with what we had.
All right. So this one's from the chat. Do you predict someone coming up with a genius idea for a system that everyone will copy, like Children of the Swamp Climb last year? There must be something, right? Way of storing or picking up?
I'm sure there will be at some point, that some team will figure out a different way to pick up that is much better than everyone else's.
I don't think there will be one that's
But I don't think it'll be
universally
very copied. I think it'll maybe it'll be copied between teams that are close to each other, but I don't see it being a very widespread thing.
There may be one that teams who don't have a good gripper all switch to, but most teams already have one that at least kind of works. They'll probably just stick with it and won't focus on improving that part.
I feel like the really good ones may be kind of complicated, so it might not be copied by everyone, but really good teams I feel like will come up with, something like a hand that is really good for some reason, just like actual human hands or something. They might come up with that, but I don't think it'll be widely copied.
Looking at other Ri3Ds, it seems like our kind of grabber with rotating for the cone to self-level was somewhat popular. So I can definitely see that being kind of a type of manipulator in this game, is the kind of self-leveling cones.
I think if there is one, I don't think it's going to be a single team that finds it and everyone copies. I think it's going to be mostly self-discovered, or a lot of teams finding it themselves that they always kind of look similar.
So on this robot, how much of stuff is stuff that we manufactured and how much was from kits or pre-made?
Kit of parts, drivetrain, modified. We swapped out the wheels at the front to be Omnis. The rest of it we made ourselves.
I mean, unless you want to count parts that are just parts, like the pistons, obviously, the motors, the compressor, all that, but pretty much other than that, I think we made most of it ourselves.
Do you think it would be possible to make it with mostly like the kits and stuff for, say, a rookie team? How much do you think would need to be manufactured?
Yeah, we had talked at one point for even like the extension arm just being a anymore climber to box, and just using that. There's definitely ways to get around it. I encourage you to kind of challenge yourselves and go for it. I mean, 1x1 square aluminum is not terrible to work with. Drilling holes and tapping aluminum is pretty easy. Running self-tapping screws in is super easy and works surprisingly well, at least for a little bit. So, I mean, I challenge every team to kind of just do it at your own level and what you can handle. But you'll learn something along the way, even if you don't feel like you can right now. So.
All right, any final comments or advice? I think we have one more question after this.
So the teams who have more than 3 days and some resources, do you recommend your type of robot plus improvements, or would you go? What?
Okay.
Sorry,
Go
what?
ahead, Ann.
I thought you were gonna read it and then you just.
Yep, this question came after I said that, so I didn't want you to think we were done.
Oh, okay. Sorry, you just
I
kind of
didn't
said
mean look it up
stared at me.
yourself.
I was like, oh, okay.
Okay.
I'll hand this over to you then.
Okay, then I'll ask that one again in a little bit. Okay, so for teams who have more than 3 days and some resources, do you recommend your type of robot, and what improvements would you go about for a different approach?
I think elevator instead of arm or some other kind of lifting. And some kind of intake where you don't have to spend any time trying to finagle with the drivetrain, picking it up, just drive over, grab, lift.
I would also probably add more than just 2 wheels to your gripper. More points of contact on the game pieces.
Yeah, I definitely improve the hand, the gripper, and as well as the arm connecting it. The whole system could be made faster and more efficient. It's kind of thrown together, so I'm maybe see if you can make like a 6-axis robot sort of style. That's probably what I'd aim to in the long run, just because those have been proven in industry and they work really well for a lot of different things. And then figure out a really good style of grabber with a little more extension or manipulation capabilities, I guess. So that's more what I change on this robot.
Overall, this design is, I think, pretty good. It could definitely use what?
Pretty rookie friendly design.
Yeah, pretty rookie friendly. And if you have 6 weeks, obviously we only had 3 days. If you have 6 weeks to just improve it, you could make this pretty good. And if you did some of the math, like getting that funneling done and making that arm the right length to allow that funnel to be in there, that would improve this robot quite a bit.
Anything else on that one? Okay, let's try this again. Any final comments or advice from you guys?
Get some drive practice. A lot of teams overlook that. And even with just a few days of it, without having to queue up for the practice field at competition, just a few days of being able to practice it yourself really helps.
I think I'll speak for our programmer here, but give your programmers time. We were able to build this robot in 3 days. Obviously, you're going to sleep, but you have 6 weeks. Please, just for the sake of them, give them just a little bit of time, maybe a week or two. But
Bus ride to competition?
Yeah. No, bus ride to competition is not enough programming time.
Well, you also gotta wire it during that time.
Oh, yeah, you're right. Closed loop control is really good. We are not using any on this robot, but it could be improved with that. Yeah, just using encoders and PID loops. If you don't know what those are, look them up. There's plenty of documentation on WPI Labs docs. Yeah, using closed loop control. 2 drivers is also very good. Most teams are using it already, but just having one driver who only deals with the drivetrain and then one driver who deals with all of your manipulators. Tends to be what works for at least my team.
I got a couple things. Going off of that note, get your programmers involved in your design, right? Get them there early on to shoot down ideas that are just not feasible. Get them idea ones so they know what the robot's going to look like before they have to program it. But two, they'll tell you where they want sensors mounted, where they want it on what implements. Shoot down any crazy ideas that may be easy to build but not easy to program. Stuff like that. Get your programmers involved in the design. It may not seem like a good idea at the time. Get them there so that they can get their input in. So.
Another thing about sensors, throw sensors on everything. Encoders are very nice. Limit switches, very good. Yeah, my team last year used a potentiometer on our turret, which held its position even on a power cycle. So we just had to recalibrate it whenever we took the turret apart. And so then we didn't have to do any zeroing. The turret knew exactly where it was on startup every time.
CAD, literally design it, have an entire robot in CAD, make your thing before you actually make it. Because if you make it before you make it in real life, you'll be able to see it, oh, that's not gonna work, or oh, that is way too impossible to make. This idea is crazy, this idea works. You'll also be able to put your sensors in place and figure out, what spacing you'll have to give it for sensors, and you'll be able to keep it within your drivetrain and within your bumpers, and you'll be able to make sure it's within size limiting before you waste materials, parts, and time on something that won't work.
Prototype, because it might work on paper, but it might not work when you actually build it.
All right, anything else?
That's it.
All right, well, thank you so much for joining us for our Q&A session. If you guys have any other questions, this video should hopefully be on our YouTube channel. You can throw comments here or any of our other videos. Hopefully we'll be coming out with a robot walkthrough, hopefully tonight, maybe tomorrow. And then any other questions, you can send them to us also on Instagram or Chief Delphi. Thanks for tuning in.
Good luck, guys.
Good luck.
Good job.